In modern physics, antimatter is defined as matter composed of the antiparticles of the corresponding particles in ordinary matter, and can be thought of as matter with reverse charge, parity, and time, known as CPT reversal. Antimatter occurs in natural processes like cosmic ray collisions and some types of radioactive decay. But only a tiny fraction of these have successfully been bound together in experiments to form antiatoms. Minuscule numbers of antiparticles can be generated at particle accelerators. However, total artificial production has been only a few nanograms. No macroscopic amount of antimatter has ever been assembled due to the extreme cost and difficulty of production and handling. In theory, a particle and its antiparticle have the same mass, but opposite electric charge, and other differences in quantum numbers. A collision between any particle and its antiparticle partner leads to their mutual annihilation, giving rise to various proportions of intense photons, neutrinos, and sometimes less massive particle-antiparticle pairs. The majority of the total energy of annihilation emerges in the form of ionizing radiation. If surrounding matter is present, the energy content of this radiation will be absorbed and converted into other forms of energy, such as heat or light. The amount of energy released is usually proportional to the total mass of the collided matter and antimatter, in accordance with the notable mass-energy equivalence equation, E=mc². Antiparticles bind with each other to form antimatter, just as ordinary particles bind to form normal matter. For example, a positron and an antiproton can form an antihydrogen atom. The nuclei of antihelium have been artificially produced, albeit with difficulty, and are the most complex antinuclei so far observed. Physical principles indicate that complex antimatter atomic nuclei are possible, as well as antiatoms corresponding to the known chemical elements.
There is strong evidence that the observable universe is composed almost entirely of ordinary matter, as opposed to an equal mixture of matter and antimatter. This asymmetry of matter and antimatter in the visible universe is one of the great unsolved problems in physics. The process by which this inequality between matter and antimatter particles developed is called baryogenesis.